Welcome to Introduction to Chemistry Lesson 1.2. In this video, we're going to be focusing a lot on the atom, especially the diagram of the atom, the atomic and mass number, along with atomic forces that operate within the atom. So let's get into it. First of all, the atom is the smallest unit of matter. It's defined as the smallest unit of matter that forms an element, and it's often referred to as the building blocks of matter. The building blocks. And that's very not neat, building blocks of matter. And what that means is that it forms elements. And for example, you can have carbon atoms, you can have oxygen atoms, but it's very important to know that you can't have water atoms. Why? Because water, H2O, is a molecule, and molecules are consisted of elements. Only elements, and its only elements, could have its associated atoms, right? So compounds, you can't have atoms for compounds. So that's a very important distinguishment you need to make, and it becomes very important when you're looking at things with the periodic table. All right, so let's look at this diagram of the atom over here, and what you will see in this diagram is that the atom is consisted of a very, very dense center, and this is going to be called the nucleus. The nucleus of the atom, and it's consisted of neutrons and protons, and what's around the nucleus are these little orbits of electrons in a way. So electrons, and it's very important, these are the three subatomic particles within the atom. So you have the nucleus with protons and neutrons, and you have the electrons somewhat orbiting the nucleus. And let's look at these three subatomic particles in a bit more length here. And obviously this diagram is not to scale, but it gives a general idea. And this is going to be an example of a proton here, and it's very important that a proton has a positive charge. And that kind of comes from the name, proton positive. Same thing here, neutrons would have a neutral charge. So we're just going to make this, just look at a little gap here, a neutral charge. And electrons will have a negative charge. All right, and these are the charges that characterize each of these subatomic particles. Another thing that's really important is to look at the relative size of these subatomic particles. And one way to measure the size of subatomic particles in chemistry is going to be the atomic mass unit. So protons have one atomic mass unit, 1 AMU. And neutrons also weigh 1 AMU. But electrons are nowhere near that size. In fact, if you want to look at it, the size of an electron is 5.47 times 10 to the negative 5 AMUs. So there's a huge disparity between the size of a proton and a neutron, which are roughly the same, versus the size of an electron. And that becomes very important when you're calculating things like mass number. All right. So what another aspect that's really important is the magnitude of their charges. So as you mentioned, the proton has a positive charge and the electron has a negative charge. And although the sizes of an electron and a proton vary significantly, the magnitude or the strength of their charge remains pretty much the same. So they could, quote, cancel out. Now here's an example here. So if I were to have some kind of atom with 2 protons and 2 electrons, what happens here is that even though the proton is bigger, the magnitude of the charge is equal. So the 2 positive charges and the 2 negative charges will just cancel out, and you'll have a neutral substance. So although this is smaller, it's a lot more denser in charge, and that makes up for it. And that's why it has the similar magnitude in charge. Okay? And the next thing we're going to look at now with this is looking at mass number here. And up in this diagram over here, we're going to look at mass number and atomic number. And this is a rough thing of what you will see on the periodic table. And what this is the element. It's an abbreviation for the element on the table. And what this is going to be the mass number and the atomic number. I'll start off with the atomic number. And the atomic number sort of characterizes an element, atomic number. And it kind of distinguishes each element from each other because that is the unique property of each element, having that additional proton. So atomic number is consisted of protons. So it's the number of protons. So proton number. So that's the positive particle in this nucleus. And what this is, the 23 up here, is the mass number, right? It's the mass number. It's the mass of the of the atom of this element. And you may be thinking, well, that's going to include the protons plus the neutrons and the electrons. But another important thing to note is that the electron size is so insignificant compared to the proton and the neutron that it isn't even considered when you calculate mass number. Right? There's no point in considering it. It's that small. So the mass number is really only protons plus neutrons. Protons plus neutrons. All right, and this is going to be really important when we're looking at the periodic table in the next video. So this is just a quick introduction to that by using the knowledge of the atom and the protons and neutrons as subatomic particles. All right, so now let's get into understanding this diagram, because to really understand the diagram of the atom, you need to understand the atomic forces that operate within the atom, right? Why are these atoms organized like this? What keeps this intact? And the first atomic force we'll look at, and it's a very important one, which you'll see a lot in chemistry, is the electromagnetic force. And what this force essentially states is that like charges repel. Repel, or they kind of like, well, repel means they do not attract, they go away from each other. And opposite charges attract. Opposite charges, they attract each other. All right, and as you mentioned earlier, protons have a positive charge, electrons have a negative charge. So in this instance, they are opposite charges, so they're going to attract each other. All right, they're going to attract each other, and this explains a very important part of the diagram up here, and it shows you why the electrons orbit the nucleus. You know, if the electrons weren't attracted to the positive nucleus, they wouldn't be in this kind of system here. They would just be out in the world doing something else. This attraction between the electrons and the protons keeps the electrons in check and part of that atom, right? All right, now let's look at this one. We have a repelling between two of the same charge, and as the electromagnetic forces state, like charges repel. So these two particles would repel because they're of the same charge. And this may bring a few questions, because, well, if you look at the nucleus, well, it's just a bunch of positive charges and neutral charges as well, but the positive charges are all come together. So what if we use the electromagnetic force, shouldn't that mean that they kind of repel and the nucleus would fly apart? Well, that brings us into the next force, and that is a very important force that operates on the scale of the nucleus, and it's called the strong force. And this force is responsible for keeping the nucleus together and overpowers the electromagnetic force, right? And it's really important to know, that the strong force only exists in small distances. In small distances, right? It does not operate over large distances, and what this does is that it holds together the nucleus, which is really important. And how this happens is between the quarks within the particles, and that gets to a different part of chemistry, but that's not too important. But it's just important to know that they hold each other very tightly, and they overcome the electromagnetic forces. So the strong force is going to overcome the electromagnetic force, and that is the essential idea that keeps the nucleus together. And this is the reason why, if the bigger the atom is, the strong force becomes weaker, because there's so much more protons. And this also gives the reason why after about 83 protons, the atom becomes very unstable. Right? So the strong force, it's what keeps the atoms together. But if you have too much positive charge, like is the case with 83 protons, that's when the atom becomes unstable and becomes radioactive. And that's very important to note as well. All right, the final force that operates within the atom is something called the weak force. And this is something we're not going to get into too much detail in, because this is the force that is responsible for particle decay. Particle decay. And what this force does is that it assists in the process in which you turn one subatomic particle to another. For example, when atoms undergo decay, a neutron can be converted into a proton. into a proton. And essentially the weak force assists in this process, and this is very important when it comes to nuclear fusion, which happens in the sun, and radioactive decay. And we'll get into this force in particular in a later video when we look at decay and beta decay and alpha decay. So that's all we need to know for now. But it's really important to just get the idea of the strong force down and the electromagnetic forces down. Alright, so in this video we looked at the diagram of the atom, the atomic and mass number. We looked at atomic forces. We also looked at the electromagnetic forces, the strong force, and the weak force. So that'll be all. Hopefully you enjoyed the video. Please consider liking or subscribing. Thank you.